Welcome to Brave Science. Today we will discuss rivers, chariots, gravitons, and a upcoming quantum gravity experiment I hope to conduct in the future. I'll give you some details about that. So, let's begin. So here we have rivers and chariots. I have come up with two different symbols to represent rivers and chariots respectively. For here, the river, you can imagine one river, right, that's flowing, and then it branches off into four different directions, four heads. And so the idea is these are all four different rivers, but it's all the same water. It all comes from one source. That's the idea that this shape is supposed to convey. As for the chariot, when I began my research many years ago, I started with this symbol. And the four colored points represented the four components of natural systems that we discussed last week, and you can see that over here to the far right, the guard, of course, the matrix, the provider, the custodian. But there was a time when I decided to stop using this shape, and I started using the Sierpinski triangle. And I continue that down to this day. I chose that because that shape is a lot more familiar to us in our culture. Ask any gamer what that is, they will tell you exactly what it is. But also the Sierpinski triangle is fractal. And our universe is fractal, our natural systems are fractal, so I thought that that would be appropriate to use a shape that is fractal to describe natural systems, which are fractal. Now, the point of rivers is that rivers will tell you the four kinds of something. And a chariot will tell you the four parts of something. So there is a difference. Let's look at a few examples. You have galaxy. Okay. What do we have here? Well, we have spiral galaxies, lenticular galaxies, irregular galaxies, and elliptical galaxies. Again, four. Four kinds of galaxy in the universe. But there are also four parts of a galaxy. Now, I am not absolutely confident on what they are yet because, I have a job, I do other things, and sometimes I don't have the time to do as much research as I would like. But I was able to find a possible candidate for the guard component of galaxies, and that is the halo you see there. You see, I put the guard component at the top. The guard goes here. The matrix is this upside down equilateral triangle. The custodian is here. The provider is here. Okay? As we mentioned last week, of course, the black hole fits all of the characteristics of a provider. Dark matter is, I've predicted, is the matrix of galaxies. And the halo, the halo is the part of the galaxy that is on the border, on the edge. And so perhaps in some manner the halo we will find out one day, or perhaps we already know. But the halo serves a specialized function of allowing certain objects and things to enter the galaxy, but preventing other things from entering the galaxy. Sort of like our atmosphere, like we discussed. Why don't we look at, but of course, the custodian of the galaxy, I have no idea. But that's what's so much fun about looking into the quadruplicity of natural systems. There's so much work to be done. So many different sorts of people can have a share in cataloging the universe. I mean, forget having a star named after you or your wife or something corny like that. You can be one to catalog a natural system. All right, so now let's look at our second example of planets. There are 4 kinds of planets, experts say. There are terrestrial, gas giants, ice giants, and dwarf planets. Okay? And the parts of a planet, there are 4 parts of each of these. There are 4 parts of a gas giant, of an ice giant, of a dwarf, and a terrestrial planet. But what I have shown here are the 4 spheres of our Earth. Earth is, of course, a terrestrial planet. And what are they, the 4 spheres? Well, there's the atmosphere, and we've discussed that is the guard component. There's the hydrosphere, and I've made that the matrix. Now, why would that be the case? Why did I think that? Well, because water is found in all of the other spheres, right? So there is water in the atmosphere, there is water in the biosphere, and water upon the lithosphere. So it connects all of us together. It connects the atmosphere, the biosphere, and the lithosphere together. And as for the biosphere and lithosphere, frankly, as I look at this today, I'm not sure if I've assigned them correctly. I'm not sure if the lithosphere would be the custodian or the provider, or the biosphere would be the custodian or provider. But when I originally examined the 4 spheres, I concluded that the biosphere was the custodian and the lithosphere the provider. But those are the 4 spheres. Okay, so now moving on to our third example, we have elements, right? And there are 4 kinds of element. We have metals, metalloids, nonmetals, and noble gases. Then you draw your chariot, and then you find the 4 parts of a metal, metalloid, nonmetal, noble gas. And what we find are electrons, neutrons, protons, and everything is held together with the strong force. So very briefly, the reason why all of this can be summed up in what I call rivers and chariots, it agrees with the 1-1-2-4 series principle in nature. And that really deserves its own video. So we will discuss that another time. So moving on to the force-carrying particles, we have, of course, the gluons, of which there are 8 for the strong nuclear interaction. There are the photons, and of course there's only 1. And we have the W and Z bosons for the weak nuclear interaction, and there are 3 of them. If you add them all up, of course, you get 12, and 12 is divisible by 4, quadruplicity. So what quadruplicity tells us in regards to the existence of gravitons, it tells us one of 3 things. 1, gravitons do not exist. 2, gravitons do exist, but there are 4 of them. And if there are 4 of them, then it would bring the number of the force-carrying particles to 16. And the third is gravitons do exist, and there are more than 4. However, if there are more than 4, the amount of gravitons must be a multiple of 4. In my opinion, I don't think the graviton exists, but it would be one of those 3. Either there are no gravitons, there's 4 gravitons, or the amount of gravitons is a multiple of 4. Now, in conclusion, quantum gravity can only be observed accompanying another fundamental interaction. That's what I find quadruplicity is pointing to about gravity. That basically gravity communicates with the other 3 forces, allowing them to exert themselves. So what am I really saying here? Well, I've drawn a wire there, and electric current is flowing along this wire. And a magnetic field is being generated. That's represented there by the red marker. What I'm saying is that gravity interacting with electricity makes magnetic fields. When we observe electricity making magnetic fields and magnetic fields making electricity, that it's not the whole picture. It's not the whole story. Gravity allows magnetism and electricity to occur in some manner that I will find to the very best of my ability. Or take a look at our friend here, Fred, who is very overweight, and he's very upset about it because it makes his life very difficult. Well, a very simple way to explain the weak force. The weak force allows for the radiation of an element to happen, and the element sheds mass by emitting it as energy in the form of light. So we have Fred here. Fred knows how to, go Super Saiyan or something, represented in the middle, and he has all of this light coming off of him. He's going Super Saiyan. So he emits this light, and then, oh, look at that. Fred has his neck back. Wonderful. So he lost all that mass by shedding it in the form of light. Well, that's what the weak force does. What I'm saying is that the weak force can't even do that without gravity saying so. And the strong force can only do what it does unless gravity says so. It serves a structural role and a communication role. So the experiment I was talking about at the beginning of the video, it's going to involve conducting a bolt of lightning to I suppose you could say, a apparatus of cables, and a car is going to be attached to this apparatus with another cable, and as you can see, the car is going to drive around a track connected to these cables. And what I'm trying to find is when lightning is conducted to a body in motion, the body being the car, will the mass of the body increase before the magnetic field appears? You see, because quantum gravity, I'm looking for it accompanying the other forces. And the thing is that to observe quantum gravity, I believe that you need to find a quantum event that is big, like a lightning bolt, or the northern lights, or interactions involving the Earth's magnetic field. A quantum event that is huge, where relativity can participate. I mean, hey, it was a bolt of lightning or a nuclear reaction. I think I'm going to go with the bolt of lightning. We know a little bit more about lightning. It's been with us a lot longer than nuclear physics, so I'm going to go with that. Because lightning is the exchange of electrons. It's the electromagnetic force. Photons are involved, and the photons have no mass. So if the car gets mass, where did it come from? If it does, I'm thinking that quantum gravity is involved, because like I said, it's my thought that gravity, it does act at the quantum level, but it enables all the other forces to exert themselves in the specific manner that they do and that we have come to find. So for our next video, we're going to have a and now for something completely different moment. So you'll get to see what that is. It'll be a surprise. And after that, we will go into the quadruplicity of natural phenomena. Don't forget to hit the subscribe button. And this is Brave Science telling you to take no one's word for it and be brave.